Dear friends, welcome to the next problem of belt drive, that is problem number 30. The data is like this. A leather belt transmits 8 kilowatt of power from a pulley that is 1.1 meter in diameter running at 200 rpm. The angle of lap is 160 degree and the coefficient of friction between belt and pulley is 0.25. The maximum safe working stress in the belt is 2.2 Newton per millimeter square. The thickness of the belt is 8 mm and the density of the leather is 0.001 gram per millimeter cube. Find the width of the belt taking centrifugal tension into account. Let us note down the given data. Here, power transmitted P is equal to 8 kilowatt, that is equal to 8000 watt. Diameter of the pulley is given 1.1 meter. Speed of the pulley is given N is equal to 200 rpm. The angle of lap theta is given 160 degree. Converting into radian, that is theta is equal to 160 into pi divided by 180. That gives theta is equal to 2.79 radian. Coefficient of friction mu is given is equal to 0.25. Maximum safe working stress F is equal to 2.2 Newton per millimeter square. That can be written as equal to 2.2 into 10 raised to 6 Newton per meter square. Thickness of the belt is given is 8 millimeter, that is 0.008 meter. Density of the built material leather is given 0.001 gram per millimeter cube. That can be written as 0.001 into 10 raised to minus 3 kilogram divided by 10 raised to minus 9 meter cube. That gives density of the leather is equal to 1000 kilogram per meter cube. We have to find out the width of the belt B. Now we know that the maximum tension induced in the belt is given by the T is equal to maximum safe working stress into cross-sectional area. So T is equal to maximum working stress F into cross-sectional area, that is B into T. So substituting these values, F 2.2 into 10 raised to 6, B is to be find out and T is 0.008, we found T is equal to 17,600 times B. Let us say this is relation 1. Now, maximum tension induced in the belt is also given by this relation, that is T is equal to tight side tension plus centrifugal tension, that is T is equal to T1 plus Tc. Let us say this is relation 2. Now from relation 1 and 2 we can compare 17,600B is equal to T1 plus Tc. Let us say this is relation 3. Here we need to calculate T1 and Tc. So power transmission by belt is given by P is equal to T1 minus T2 into speed of the belt V, where speed is given by V is equal to pi diameter of the pulley D into speed, that is RPM of the pulley divided by 60. On substitution of value, that becomes pi into 1.1 into 200 divided by 60 and it gives Speed of the belt V is equal to 11.52 meter per second. Now, using above relation of power, that gives us 8000 is equal to T1 minus T2 into 11.52. So it becomes at T1 minus T2 is equal to 694.44 Newton. Let us say this is relation 4. We also know that the ratio of tensions of tight side and slack side of belt is given by T1 upon T2 is equal to E raised to mu theta. Upon substitution of value, it becomes e raised to 0.25 into 2.79, and it gives on calculation T1 upon T2 is equal to 2.01. So rearranging, it gives T1 is equal to 2.01 T2. Substituting this value in relation 4, we found 2.01 T2 minus T2 is equal to 694.44. Hence, on rearranging and calculation, we found T2 is equal to 687.56 Newton. So it gives us T1 is equal to 2.01 into T2. Substituting value of T2, we found it is equal to 2.01 into 687.56. So T1 is equal to 1381.99 Newton. And the centrifugal stress Tc is given by Tc is equal to mv square, where m is mass of belt per unit length, and that is given by m is equal to mass of belt per unit volume into cross sectional area, and this is nothing but mass density into cross sectional area. So that gives m is equal to rho into b into t. On substitution of values, m is equal to 1000 into b into 0.008 gives us 8 times b kilogram per meter. So substituting the values in the equation Tc is equal to mv square, it becomes equal to 8 times b into 11.52 square, and that gives centrifugal tension Tc is equal to 1061.68 times b Newton. Now substituting the values of T1 and Tc in relation T, it becomes 17,600 times b equal to 1381.99 plus 1061.68 b. So rearranging the terms, we find 16538.32 b is equal to 1381.99, and hence b is equal to 0.08356 meter. So it can be written as width of the belt B is equal to 83.56 millimeter. So we can conclude that the width of the belt is 83.56 millimeter. Thank you, friends.